we can place a new data in a linked list in 3 places, right? One is at the beginning of the list or at the end of the list, and another is in the middle of the list or between two elements. We can insert a new element. That is the insertion operation. So another operation of linear linked list is deletion. What is deletion? A linked list is given, just you have to delete a data element, right? So just like the insertion operation, we can delete a data from several positions. Just look at this list. This is a linked list, and how many arrays are here? Two one-dimensional array, one for containing the data and another for the addresses, right? But why we need two one-dimensional array in a linked list? Because in linked list, each data element is stored in a node, and that node is divided into two parts, right? The first part contains the information or the data or the content of that node, and in the second portion, in the second field, you can store the address of the next data element. That's why we need two one-dimensional array. And these 1, 2, 3, 4, 5, 6, 7, 8, these are the index or position of the nodes. Okay, so how many data elements are here? 5 data elements, and start equals to 1. So in this position, we will get our first data element, which is A. And so here start equals to 1. So A is the first data element, right?
Yes, ma'am.
So which one is the second data element?
C.
The pointer value is 2. So C is the second data element, and then 4, which means E is the third element, then B, after that D. And here the pointer value is 0. That means D is the last element of this list. Okay. Now we want to delete from the back. That means we want to delete the last data element of this list. Okay. So which one is the last data element? D, and it's placed, it's stored in which position? 5. If the operation is delete a data from the back from the linked list, then we need to find out the position of the last data element. So here D is the last data element and its position is 5. So here LP, that is last position, equals to 5. And another node we have to find out, that is which one is the previous node of D. If D is the last element of this list, then D is the second last element of this linked list, isn't it?
Yes, ma'am.
Yes, ma'am.
Yes. Which one is the last data element? D.
D.
And the element, the previous element of D is B. So here BLP, that is position before last
Then
position.
Second last
Yes.
is E, I guess.
Why second last is E?
Because the
We have
previous
to
one is E.
use these array. We have to use these array for finding the next elements. Okay. The first element is A because start equals to 1, and here which value is stored here? 2. That means the next element is in position 2. That is C is the second element. After that 4. That means E is the third element. Then the pointer value is 3, which means D is the fourth element, and the last element is D.
D.
So here LP equals to 5. That is our last element, and 3 is the position of second last element, isn't it? So why we need to find out the position of the second last element? Because when we will delete the last data element, at that time B will become the last element of the list. In this list, D is the last element and B is the second last element. But after deleting the last element, now which one will become the last element? B.
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 Right? If we delete the last element, that is D, after that which one will be the last element? Obviously
B.
B,
B, ma'am.
right? And after deleting an element, if we delete D, now an empty space will be created here. And that element will become the first available space of the list. Here now the first available space is 6 because avail equals to 6. But when we'll delete D at that time, this position 5 will become the first available space. So here actually how many changes we have to make? Three changes. One is at first delete the last element and then make the second last element as the last element of the list. After that, change the value of available. Change the value of avail. So at first we have to find out the position of last data element and the position of second last data element. So here LP equals to 5 and BLP equals to 3. Then step number 2, delete at data LP. Delete the data element which is in which position? In the last position. So delete a data from position 5. So this is our new list and here we already deleted the data D. After that, step number 3, set next LP equals to avail. What is the value of avail? 6. Now it will be assigned where? We can assign it where? At next
Next to
LP,
5.
right? And LP equals to 5. So now next 5 equals to 6. What does it mean? That means 6 was previously it was the first available space, but after deleting the data element from here, now it has become the second available space of the list. That's why we have created a link here. Now this position 5 is the first available space and 6 is the second available space. That's why next 5 equals to avail, that is 6. Then step number 4, set next BLP equals to 0. When we deleted the last data element, now B is become the last data element. And we have to place 0 where? Next equals to 0. If B is the last data element, then we have to place 0 here, right? And this 0 indicates that B is the last element of the list, and that is step number 4. Set next BLP, and here BLP equals to 3, so next 3 equals to 0. So in this new list, B is the last data element. Step number 5, set avail equals to LP. LP equals to 5. LP is the position from where we deleted the data, right? So now it will become the first available space. Is it clear what we have done here? Just delete the data from the back, that is delete the last data element from the list. So you have to find out the position of two data elements. One is the last data element and another is the second last data element. Why I need to find the second last data element? Because after deleting D, it will become the last data element. Okay? And when we delete a data element, that means we are creating an empty space, and that space will become the first available space of the list. Is that clear?
Yes, ma'am.
Sure.
Yes,
If you
ma'am.
have question or confusion, you can ask me. At first, find out the position of last data element and the position before last position, that is the second last data element, and then
In
delete.
3,
Yeah.
set next LP is equal avail.
Okay. So when we delete this data element D, after deleting it, now this is an empty space, right? This is an available space which can be used for, inserting a new item, isn't it? When you deleted D, now it is an empty space, and that empty space should be considered as the first available space. That is, now after deleting D, if we have to add a new data item, where we will add it? Obviously in this position. When
Yes,
we
ma'am.
delete a
If we
data
add,
item, sorry,
ma'am, if we add, then this 6 position.
yeah, then again 6 will become the first available space. But the thing is, after deleting the data item, we have to make it the first available space. That's why in step number 3 we did it. Just we assigned the value of avail where next LP. LP equals to 5. So now next LP equals to avail. And that is the value of avail, right? Avail equals to 6. Clear. And then step number 4 sets next BLP equals to 0. Our data element is already been deleted. So which one will be the first, or I mean last element? Obviously B, right? And if we want to make it the last data element, obviously its pointer value should be 0. That means there is no other element we can find after B. So that's why next 3 equals to 0. And step number 5 set avail equals to LP. LP was the position of last element 5, and it is now the value of this point at avail. Avail equals to 5. Clear?
Ma'am, but in their last position is B, ma'am. 0.
Sorry, in
Ma'am, clear, ma'am.
hello?
Yes, ma'am, clear.
Clear. Okay. Okay. Now the next algorithm is if we want to delete the data element from the middle of the list. This is another array where start equals to 1. So A is the first data element, and then C, after that E, and B is the last data element. Suppose after deleting D, now we want to delete another element from the middle of the list. So we need to know from which position we want to delete the data. So here the position is given. Deleted position equals to
Second
2. So we want to delete the data item from position 2. That means delete C. Avail equals to 5. So this is the first available space. Okay. So now C is between which data elements? C is between A and E. The previous data of C is A and the next data of C is E. But when we will delete C, at that time it will become an empty space. Position 2 will become an empty space. That means there is no data element between A and D. Right?
A and E.
So at that time we have to make E as the next element of A. After deleting C, now we have to make E as the next element of A, but in this list actually C is the next element of A. So how many things we have to find out, how many positions we need to consider? First one is the position of deleted data element dp equals to 2, and another is the position before C, that is A. Step number 1, find the deleted position and previous position. So 2 is our deleted position because we want to delete C, and the previous data element of C is A, which is in position 1. So previous position equals to 1. Then step number 2, delete at data dp. What is the value of dp? 2. Okay, so data 2, that means C, we have to delete it. So after deleting the data, now this position 2 become an empty space, right?
Yes, ma'am.
Which
Yes,
data
ma'am.
element was deleted? The data element from position 2. Now the next step is set next pp equals to next dp. That means now E will become the next data element of A. Initially in this list E was the next element of C, but in the new list there is no C. C is already been deleted. So E will become the next data element of A. Then step number 3, set next pp equals to next dp. What is the value of dp?
4.
The value of dp is 2, and
two, ma'am.
next
It will
4,
be
I mean next 2 is 4, which will be assigned where? At next pp, and pp equals to 1. So now next pp, next 1 equals to 4, which is the value of next dp. And step number 4, set next dp equals to avail. That means again we deleted which data element? C. So now it will become the first available space. So the previous, this 5 will become the second data element, right? So set next dp equals to avail. Avail equals to 5. So now next dp equals to avail. The last step is set avail equals to deleted position. The deleted position was 2, and now it is the first available space of the new list. Is that clear? In this algorithm, what we have done, we just deleted a data element from the middle of the list, right? So we need to find out the position of that deleted data item and the previous data element of that data item, right? So here dp equals to 2 and the previous data item is a and its position is 1. So dpp equals to 1. So which data element will be deleted from position 2? So delete at data 2. So after deleting this data item, now this position 2 will become the first available space. Set avail equals to dp. If it is the first data item, that means the previously avail equals to 5. Now 5 will become the second available space. So if you write set next dp equals to avail, then we can assign that data element for in next dp. Hello, is that clear?
Yes, ma'am.
Yes, ma'am.
So
Yes,
what is the
ma'am.
difference between the previous one and this one? When we deleted the data from the back of the list, at that time we needed to change how many things? We needed to change the last position, right?
Yes, ma'am.
In the previous one, we deleted the last data element D, but after deleting it, we had to make B or the second last data element the last data element. But in this one, when we deleted the data from the middle, at that time, which data element was changed? Hello. How many changes we had to make here? At first, we deleted the data item C and then we made E as the next data element of A, right?
Yes, ma'am.
So you
Yes,
can do
ma'am.
one thing, it will be more clear to you if you practice it. Okay, so I'm just giving you another list. Suppose now the list has some numbers. Okay, so 10, then 15, then 20, then 25. Okay, so the list has 4 numbers and their positions are 1, 2, 3, 4, 5, 6. Okay, and these are empty spaces. So what will be the value of start if the data is sorted? Then what will be the value of start? 2. Very good. So here start equals to 2. So this 10 is the first data element, and then 15, which is in position 4. After that 3 and then 6, right? And 25 is the last data element, and avail equals to 5. Avail equals to 5. So this is the first available space and then 1. So now you have to delete the data item 20. Delete 20 from this list. Can you do it?
Yes, ma'am.
Yes, ma'am.
Yeah, so at first we have to find out how many things? The position of last data element.
The deleted position.
Deleted position. So here deleted position equals to 3. Okay, and then the previous position. So previous position equals to which data element is the previous data of 20?
15.
15. So 15 is in
15.
position 4. After that, delete at deleted from position dp, right? The next step is delete at data dp. So which data element will be deleted? Here dp equals to 3, so 20 will be deleted, right?
Yes, ma'am.
Okay, so after deleting 20, now this is an empty space. In this list, 20 is a data which is placed between 10 and 15, right? Sorry, between
Yes,
15
ma'am.
and 25.
25. Yes,
Between
ma'am.
15 and
25.
25. So here, previous position was 15 and next position was 25. Isn't it?
Yes, ma'am.
Yes, ma'am.
So what will be our next
So the
step
next
now?
of
25 will become the next data element of 15.
yes, ma'am.
25 will become the next data element of 15. So how we can write the steps in the algorithm?
Next previous position
Very good. So
will be
next
6.
previous position equals to,
Will
sorry,
be 6.
equals to next deleted position. That
Next
is the
deleted
step of
position. Yes.
algorithm. Next pp equals to next dp. So here deleted position was 3 and next 3 equals to 6, and we can assign it where? In next pp, and pp equals to 4. Right? Next pp, that is next 4 equals to 6. So where we will write it? Here. So now next pp, that is next 4 equals to 6. Then what will be our next step? The next step is now this value of avail, where you can assign it. This value of avail will be
Ma'am,
assigned
in
at
3, ma'am.
next deleted position. So our next step is set next deleted position equals to avail. What is the value of avail? 5, right? And we will assign it where? This is our array next. So next deleted position, next 4 equals to, sorry, next equals to 5. This is an empty space now, okay? And it will become the first available space, and now 5 is the second available space is the of the list. And the last step is avail equals to deleted position. That is the last step. So now the new value of avail equals to deleted position, that is 3. Clear?
Yes,
Yes,
ma'am.
ma'am.
So that is the deletion operation of linked list. Okay. Now we'll discuss the last operation of the list, linked list, that is search. So what is search operation? Search operation means a data item will be given. Suppose from this list we want to find out 15. So how we can do it? We can see from this list, we can see that 15 is in position 4. So if we access the data from this position, then we will get 15. But linked list is a linear data structure, right? So we cannot just start from here. We have to start from
The beginning.
the value of start pointer, or from the beginning of the list. So how we can do it? Obviously, we need an algorithm. Okay, so this is the algorithm of search operation. In this search operation, we need to know how many parameters? 5 parameters. Info, that is the array name where we can contain all the data, and link is the array of address of the next data element. Start is the pointer which will tell us that this data item is the first data item. Item, that is the data we want to search, and location of that data item. In this search operation, we need to have how many parameters? 5. One is info, the data array, link, that is the next array, start pointer, then the data item, and location of that data item. But actually the outcome of this algorithm is the location of that item. In search operation, if we want to search a particular data item, we need to know in which position that data item is located. Isn't it?
Yes, ma'am.
So suppose the data item that we want to search is not, that data item doesn't belong in that list. At that time, location will be null. Location equals to null, which means the data item is not placed in that list. But what if suppose the data item belongs to that list? Now, how we can search that data item? Step number 1, set pointer equals to start. This is a linear data structure, so maybe we have to search in several locations. That's why we need a pointer, or we need a actually variable. we need to use a loop here, and for continuing that loop we need a loop variable which is pointer. And the first step is set pointer equals to start, or I'm just creating a list. Okay, so suppose this is list in 4 data items. And the positions are 1, 2, 3, 4, 5, 6. And what is the name of this array? What is the name of the array? In that algorithm, they used info, right? The name of this array is info. And what about the second array? The name of the second array is link. Or you can use any other name. Okay, and this list has 4 elements, suppose ADCE, and if the array is alphabetically sorted, then start equals to 1. Now can you create the link between the elements? A is the first element, then the second element is
C.
C, that means here we have to write 3, very good.
3.
And then
D,
D,
so 2.
so it will be 2. And then the last one is E, which is in position 5, so it's 0.
0.
Okay. And suppose avail equals to 4. So this is our first available space. And then 6, then 0. Okay. Now from this list, we want to search the data item D. So here start equals to 1. Although we don't need avail here because we are not going to insert any new data item or delete any item. So which data item we want to search? D. Right, and the location of D is 2, but we have to find it out through that algorithm. Here the location of D is 2 and it will be the output of this algorithm. So what is the first step? This linear data structure, so we have to search in so many locations. We need a obviously variable. Suppose the variable is pointer, or you can take any other variable such as I, J, K, or any other. Okay. Suppose set pointer ptr equals to pointer, and what will be the initial value of this variable? This linked list is a linear data structure. That means we will start the searching process from the first memory location. And from this pointer, we know that this 1 is the first memory location. This is the position of the first data item. So the initial value of pointer will be star. Pointer equals to
1.
star, right? And then now the next data item is, obviously we need a loop. So step number 2, repeat step 3. What will be the condition? What will be the condition? Repeat step 3 while pointer not equals to null. Pointer not equals to null. And step number 3 is, if item equals to info pointer, then set location equals to pointer and exit. Otherwise, else set ptr equals to,
Link,
what should we write? Link ptr.
link pointer.
Yeah. Okay. And then step number 4 will be set location equals to null and 5 exit. So this is our algorithm. Okay. In step number 1, we just initialize the variable pointer. Pointer equals to start. So here start equals to 1. That means the initial value of pointer is 1. Okay. In step number 2, repeat step 3 while pointer not equals to null. So here pointer equals to 1, it's not null. So if item equals to info pointer, then set location equals to pointer. Okay. So info is the name of the array, and what is the value of pointer? The value of pointer is 1,
One.
and from this info array we can see that info 1 equals to a,
A.
right?
Yes, ma'am.
And a is not equals to item because item equals to d.
D.
So if item not equals to info pointer at that time, set pointer equals to link pointer. That means we have to change the value of pointer. So what will be the new value of pointer? Link 1 equals to 3. So 3 will be the new value of pointer. Look at step number 3. If item not equals to info pointer, then set pointer equals to link pointer. That means in the first position we didn't find our desired data item D, so we have to find that data item in which position? In the next position. And where will get the next position? From this pointer value.
Ma'am, you
Link
write
1 equals to
item equal. Ma'am, you write item equal
where?
info in the step number
Yeah,
3.
so if we got the info pointer at, I mean if we got item in info pointer, then we can set location equal to pointer. But I said that if item not equals to info pointer, then
It will
set
get
pointer equals to link pointer.
else
Okay,
else,
ma'am.
yes, ma'am.
You got the
Okay,
point. If item not equals to info pointer, then set pointer equals to link pointer. What does that mean? This info and pointer equals to 1. Its value is a, which is not item, which is not d. At that time, set a new value in which variable, pointer variable. And what will be the new value of pointer? It depends on this link pointer. So here, the new value of pointer will be link 1 equals to 3. Link pointer equals to 3, and we can assign it where? In variable pointer. Okay, then again we have to execute the same statement. We have to check whether info pointer is equals to item or not. So now the new value of pointer is 3. So info 3 equals to, what is the value of info 3?
C.
C.
C, which is not D. Again, we didn't find our data item D in position 3. Again, set pointer equals to link pointer. So what will be the new value of pointer?
2.
2.
Very good, 2. So here link 3 equals to 2. So the new value of pointer is 2. Again, we can execute the same statement. Info pointer, what is the value of pointer?
Pointer
2. And info 2 equals to D. That means
D.
now
Does match.
it satisfies this condition. If item equals to info pointer, then set location equals to pointer, right? So now location equals to, what is the value of pointer? 2. That means our data item D is placed in which position? D. That is the search operation. If we want to search a data item from a list, we need to find out in which position that item is stored. Okay, and by following all these steps, we can find it out. Is that clear?
Yes,
Yes,
ma'am.
Okay, so in this process, we just need a variable for loop. Okay, and then we just need to check whether that data item, or whenever you are actually assigning a data where in that variable, and that time we need to check whether that data item belongs to that position or not, stored in that position or not. If not, then change the value of pointer. Otherwise, set location equals to pointer. Clear?
Yes, ma'am.
So that is the end of, I mean, before first term exam, we will not discuss any other topic. So how many operations you just did from linked list? Only 3 operations, that is insertion, deletion, and searching. And we perform those operations on which type of linked list? In single linked list. And after first term exam, we'll discuss about the doubly linked list and circular linked list. Okay, so now tell me if you have any problem in the previous chapters, that is chapter 1, 3, or in array in linked list, you can tell me.
Ma'am, I have a problem of big O.
Okay.
Ma'am, in space complexity.
In space complexity. Okay. So when we use big O notation, for just denoting the time complexity or space complexity of an algorithm. I'm just writing a simple problem here. Suppose we want to calculate the product of some numbers, right? And we can write that algorithm or program in two ways. One is, suppose the input size is given, okay? So in how many ways we can do it? Suppose a variable is integer p equals to 1, integer I, then for I equals to 1, I less than or equals to 4, I plus plus, then p equals to p into I, and another code segment is integer I n, integer p equals to 1, for I equals to 1, I less than or equals to n, I plus plus, p equals to p into I. So now tell me, for solving which type of problem we just written this code. First, try to find out the problem. Why we need this code segments for solving which problem we need this code segments.
To solve the product of a
Very good.
sequence.
For calculating the product of some numbers, right?
Yes.
And in this first code segment, we declared how many variables? Two variables. One is p and another is I. And in the second code segment, we have how many variables? Three variables, I, n, and p. Okay? And time and space complexity, we know that there are some functions in respect to their input size. F of n, that is the time complexity or space complexity, and n is the input of that program or algorithm. That means always the time and space complexity depends on the input size. So it's really important to find out how many input variables you are using in the program. In the first code segment, just tell me which one is the input variable. Or did you use any input variable? No.
No,
I is not input variable, this is a loop variable. This p is an output variable and I is a loop variable. That means we didn't use any input variable here. And in the second code segment, we have three variables, I, loop variable, p, output variable, but we used an input variable, n. And always the time and space complexity depends on the input size, not on the other variables. Okay? So now if we solve the first code segment, where in this condition we can see that we always will calculate the multiplication of four numbers, 1, 2, 3, and 4, because the initial value of I is 1 and the maximum value is 4. So we will execute this for loop 4 times for 4 different values of I from 1 to 4, and the result will be always 24, right? The result is always 24. How this code segment works: at first we'll take the the value 1, I equals to 1, and then test the condition 1 less than 4. If it is true, then execute this statement. There is only one executable statement, that is p equals to p into I. So when I equals to 1, the condition is true, so just execute the statement p equals to p into I. The previous value of I is 1 and I equals to 1, so 1 into 1 equals to 1, and then I plus plus, just increase the value of I plus plus, that is I equals to I plus 1. The previous value of I is 1, so now the new value will be 2, right? And at that time p equals to the previous product 1 into the new value of I, that is 2. So 1 into 2 equals 2. In that way we can find out the result 24. For how many numbers? For 4 numbers. Okay. So what about the second code segment? In second code segment, the condition is I less than or equals to n. So here the output is not fixed. We don't know which one will be our output because we don't know how many numbers we want to take. We can take different input size, we can take different numbers in this program. The value of n can be 4, it can be 5, it can be 6. So the output is not fixed and it depends on n, right? The output depends on n. And when the input, I mean the time complexity or space complexity doesn't depend on the input size, the complexity will be order of 1. The space complexity of the first code segment is order of 1 because here we didn't declare any input. And always space complexity is the amount of space the input variables can take from the memory location. But here we don't have an input variable, right? That's why the space complexity is order of 1. But in this code segment, we have one input variable and the value can be changed. For different value of n, the output will be different. That means here, it depends on
N.
N.
so what will be the space complexity?
1.
Order of 1.
Order of
1.
1.
why order of 1?
Time complexity is order of n, but space complexity is order of 1 since we are using on variable there, input variable.
Very good.
Yes.
Here what will be the space complexity? The space complexity will be order of 1 because we have only one input variable. And what about time complexity?
Order of n.
Order of
The
n.
number of operations we are performing here. How many operations?
Unknown.
We have to perform here 2 operations. And here the number of operation doesn't depend on the input size. That's why the time complexity is also order of 1. In the in this code segment, the number of operation depends on n, right? That's why the time complexity is order of n. Is that clear? In
Yes,
time
ma'am.
complexity,
Ma'am, will you please
Yes, ma'am.
find out 2 things. One is how many operations you have to perform here. So in time complexity, you just have to find out the number of operation and whether they depend on the input size or not. Okay, and in space complexity, how many variables you are using, how many variables you have declared. Clear?
Yes, ma'am. Ma'am, will you show us an example for space complexity or order of n?
Order of n, okay. So think about matrix multiplication or matrix addition. In matrix multiplication or addition, we need some array. We need array variable, right? Or forget about matrix multiplication. Suppose we are writing a program where we need to use several inputs, okay? So A10, what does that mean?
We can input 10.
Yes, so
10
here,
variable
how
of
many-
a.
Yeah, so how many variables there are? 10 variables. And for these different 10 variables from A0 to A9, how many storage we need?
10.
How many memory locations we need? N number of
40.
memory locations. N number of memory locations, that is 10 memory locations. Suppose this is our memory, and if the size of integer type data is 4 bytes, so each of these data item A0, A1, A2, A3, they will take 4 bytes from the memory. So there are how many memory locations we need? 10 consecutive memory locations. So at that time, the space complexity will be order of n. Clear?
Yes,
And what
ma'am.
about order of n square? Just think about matrix addition or matrix multiplication. At that time, we need 2 arrays, or actually we need 2-dimensional array.
2-dimensional.
Dimensional array. At that time, the space complexity will be order of n square. Okay.
Yes, ma'am.
Okay. So, do you have any problem in array or linked list? Because that is a recent things we discussed. So if you have any problem in those topics, you can tell me. No problem.
Ma'am, 18, I have a written exam from 3:20 to 4:30. Can I join the Viva at 5 p.m.?
Sorry.
Ma'am, actually, I have written exam on the day 18, and that is from 3:20 to 4:30, and I have Viva from 4:35, I think. So, can I join the Viva at, ma'am, 5?
Okay. Okay. No problem.
Thank you, ma'am.
So you don't have any other problem in any topic.
How to
Yes.
find the pointer value? Can you please show it that one?
How to find pointer value where? In which operation?
Ma'am, in array, two-dimensional array, in one is data name and another one is next.
Yes. Okay, the list will be given in the question paper. The list will be given if the list is not sorted. Look at this. Suppose this is a list, and in linked list, it's not mandatory that the data should be sorted. List can have some unsorted numbers. Okay. So one way is if the list is unsorted, then it will be given in the question paper. So here suppose start equals to 2. For a sorted list, if the data item is A, B, C, D, and if you know the value of the position of first data item, then it's really easy to set up the other links, create the other links, right? If the list is sorted, then how we can set the value of pointers? Hello. If it is a sorted list, can you create the link between the data elements?
Yes, ma'am.
Really easy, right? The
Yes,
first
ma'am.
data item is written A. For
A.
alphabetically sorted list, the data next data item should be B,
B.
right? And B is in memory location 4. So here
4.
the pointer value will be 4,
4.
right? And now the third data item will be C, which is in
1.
memory location 1. So here we have to write 1. After that,
5.
after C, the next data element is D, and it's in position 5.
5.
Okay, and the last data is D.
0.
Here we can write 0. So it's not that difficult. If the list is alphabetically sorted or numerically sorted, then you can use this formula. But what if the arrays are, the list is not sorted? At that time, the pointer value will be given. Clear?
Yes, ma'am.
Yes, ma'am, clear.
Okay. Any other question?
Ma'am, actually, I have a
Yeah.
problem. I have three exams today, tomorrow, then one Viva.
Sorry?
The data structure Viva also tomorrow. Ma'am, if you allow, the Viva will be tomorrow next day. I mean, 1 day or 2 days later, I can do.
Okay. Okay.
And
So
my CL
tomorrow
number
is a
one.
written exam. Okay. So I'm just requesting you, please don't try to copy. If I find any similarities, believe me, I'll deduct some marks. Some marks will be deducted seriously, and I'll do it in first term exam. So don't try to do it. Okay. Now please respond. 1,
Yes, ma'am.
2. Just give me a minute.